All right, today we are diving into a system that's pretty much hidden from view but saves lives across the globe every single day. It's an incredible story, really. It's about a single label, a journey that cannot afford any mistakes, and the global safety net designed to protect something called living medicine.
So let's just start with a question. Picture a bag of life-saving stem cells. They're donated in, say, Germany, processed in the United States, and now they're on their way to a patient in Australia. How in the world do you track that specific bag and make absolutely sure it gets to the right person without a single error? I mean, we're talking about one of the most high-stakes journeys in all of modern medicine. This isn't like a bottle of pills. We're talking about cellular therapies. A mix-up here isn't just a simple mistake. It could be absolutely catastrophic. The system has to be perfect. And that brings us to the core challenge, right? How do you build a system that's so tough, so reliable, that it can track a single product from a donor to a recipient and back again, no matter where they are on the planet? Well, the answer lies in a concept called traceability.
Traceability is the absolute bedrock of safety here. It is our global safety net. Think about it. If there's a problem, maybe an infection, or the cells just don't work as expected, this system lets medical teams rewind the take. They can trace that product back through every single step of its journey to figure out exactly what happened.
So how do you even begin to tackle a problem this big? You do something that sounds simple but is incredibly powerful. You create a universal language. You build a standardized information environment, like the global standard known as ISBT 128 that everyone in every country agrees to use. Now, this global safety net, it's not just one thing. It's actually built in layers, kind of like a pyramid. So let's do this together. Let's build this system from the very foundation all the way to the top. And the foundation, the most critical layer of them all, is terminology. I mean, before you can track anything, everyone, from a lab technician in Tokyo to a doctor in Toronto, has to agree on precisely what to call the product. If you don't have that shared language, the whole system just falls apart. And what's really fascinating is just how specific this language gets. To describe any given product, the system standardizes three key things. First, its source. What kind of cells are they and where did they come from? Second, its core attributes, like what temperature does it need to be stored at? And third, any modifications. Has it been frozen? Has it been enriched in some way? So, once everyone is speaking the same language, we can move to the next layer. This is where we take those standardized terms and combine them to create a totally unique identity for any product you can possibly imagine. Okay, let's look at a real example. Here we've got a product that was sourced using apheresis, which is a way of separating out parts of the blood. Its core attributes tell us it has a citrate anticoagulant and needs to be kept super cold, below minus 150 degrees Celsius. And it's been manipulated, it's been cryopreserved. You put all those pieces together and you get one single, clear description, no confusion. And this is what's so brilliant about the system's flexibility. Here's a totally different product. This one is from bone marrow, it's just refrigerated, and it's been enriched for mononuclear cells. The same set of rules creates another perfectly unique description. There is absolutely zero chance of mixing this product up with the last one. Okay, so now we have this very specific but kind of long text description, but having humans read and type that all the time is slow, and people can make mistakes. So the next logical step is to convert that entire description into a unique product code that a computer can read and understand in a fraction of a second.
All right, you've got the code. Now what? You need a way to send it, right? A delivery mechanism. This is the layer that makes sure the product's digital identity can literally travel with its physical form, all across the world, seamlessly and with perfect accuracy.
You know, the classic barcode, the one with the lines? It's okay, but it can only hold a tiny bit of info. The modern standard is the 2D data matrix. And just look at the difference. A single tiny little square can hold all the information of several of those old bulky barcodes. It's way more efficient, much more reliable, and it's perfect for the small labels on these critical medical products.
And now we have reached the top of our pyramid. This is it. This is the final, most critical layer, where everything we've just built, the shared language, the unique codes, the delivery system, it all comes together on one standardized label. This is probably the single most important point of contact in this entire global journey. So let's break this label down. First, and maybe most importantly, is the unique donation ID. This is not just some random number.
This is the unbreakable digital chain linking this product all the way back to the original donor and the specific moment of donation. It's how we can always trace the cells back to their source. Next up, we have our product code, and you'll often see inside that 2D data matrix we just talked about. This is the digital summary of everything we've been building: the cell type, the source, the storage conditions, all of it. One quick scan tells the system the entire story of what's inside that bag. But hey, technology isn't everything, and this part is so important. The system also requires that the most critical information for a human, things like blood type, the expiration date, is always printed in the exact same spot on the label. This means a nurse in any hospital anywhere in the world can glance at it and find what they need instantly, which dramatically cuts down the risk of human error. And that really gets to the heart of why this all matters. As the source material says, it's not just about making things look neat. Standardizing the layout, making sure everyone knows where to look for critical info, is an incredibly powerful tool for patient safety. It removes confusion and, simply put, it saves lives. So, when you step back and look at the whole picture, you see it, right? Safe, reliable, global traceability isn't some kind of magic. It's the result of all these key elements working together in perfect harmony, from that first unique ID for the donor, to the standardized description, all the way to that final uniform label. This whole system is pretty amazing. It proves that we, as a global community, can come together to create a universal language to solve a genuine life-or-death problem. And it kind of makes you wonder, doesn't it? What other huge, complex, global challenges could we solve if we just started by agreeing on the words to use first? Thanks for watching.